Hello, my dear students. Welcome to my channel. We now start a new chapter, chapter number 3. This is pair of linear equations with two variables. Now let us go for introduction. Now we know different types of equations and let me write down one by one. If I write x plus 2 minus 5 is equal to 0. Suppose this is one equation. You can observe the power on x is 1 and only one is the variable, that is x. Now this is called a linear equation. Okay. Now we will go for one more example. In this, let me write down 2x square plus 3x minus 4 is equal to 0. In this, you can observe again there is only one variable, that is x. Here also same x, but the degree is 2. That is the maximum power or maximum degree of the equation. Now such equations are called quadratic equations, right? Now we'll go for the third example. Here let me write down 4x cube minus 2x cube 2x square plus x plus 1 is equal to 0. I am writing randomly whatever I think, but to give an example. Here you can see again there is only one variable, that is x. In all these terms you have only one x, but the powers are varying. Here you have 1, here you have 2, and here you have 3. What is the maximum degree of the equation? Yes, you are right, that is 3. Now such equations are called cubic equations. Now in this chapter we are dealing with only linear equations with two variables. Therefore, let me concentrate on the first one, that is linear equation. Now, let me write down one example here. 2x plus 3 is equal to 0. You know, I am writing one linear equation but with only one variable, that is x. But this chapter is dealing with linear equation with two variables. Therefore, this equation is of no use. You have to write down another equation with two variables. 2x plus 3y minus 2 equals 0. Here you can observe I have written one linear equation. Why it is linear? Because there are two variables with only one power on the top. Therefore it is linear, but there are two variables. One is x, another is y. Therefore it is linear equation with two variables, that is x and y. Now, what is general format of this equation? That would be ax plus by plus c equals 0. In all the types of equations, be it quadratic or cubic or linear, you have one general formation of equation, and that we should follow whenever we solve the equations. This is the general formation of a linear two variable equation. Now, this chapter is dealing with one more set of equation. That's why it's called pair of linear equation. To have a pair, you should have one more equation. This is one equation. Now I have to write down another equation. That equation, suppose I write 3x 2y 4 equals 0. This is second linear equation with two variables. Again, this also follows general formation ax plus by plus c equals 0. Now boys, these equations look similar. I cannot distinguish between these two general formations. One is for the first equation and second for the second equation. For the distinction, what we do, distinguishing, you write a1 for the first equation, A2 for the second. Similarly for B1 and B2, C1, C2. A1, B1, C1 is all pertain to first equation, while A2, B2, C2 pertain to second equation. Now, we go for certain comparisons for solving the questions. We can solve the question by two methods. One is graphical and second algebraic. Now in this chapter we are going to deal the first method, that's called graphical method. Now let me give you examples in the next page. Suppose we have two equations that we saw. One is 2x plus 3y minus 2, 2x plus 3y minus 2 equals 0. And other one was 3x plus 2y plus 4, 3x plus 2y plus 4 equals 0. I am taking the same example. Here we compare A1 and B1. What is A1 here? A1 is 2. What is A1? The coefficient of first equation, and the A2 is the coefficient of the second equation, that is 3. And now B1 and B2. What is B1? B1 is plus 3 and B2 is 2, and this is C1. C1 is minus 2. Now I have small thing to advise you. Whenever we have minus, don't get confusion whether this minus belongs to equation or the coefficient or the constant number. I will explain you. We just divert a bit and write down here. Any general formation, for example, ax plus by plus c equals 0. In this plus is compulsory, right? Now, if at all there is a minus sign, it would look like this: ax plus by plus of minus c. Because whenever we have a minus sign, you should make sure that plus exists in the equation and minus is carried to the number. It can be for B, it can be for A, or it can be for C. This is how it looks. Now here also there is a plus here, and then in the bracket this minus 2 is written. That's why when you open the bracket, that plus into minus becomes minus. Minus 2 is C1 and plus 4 is C2. When we compare A1 by A2, that is 2 by 3, and B1 and B2, 3 by 2, C1 by C2, minus 2 by 4. Now let me remove these equal signs put here. Is this A1 and by A2, is that equal to B1 and B2, or is that equal to C1 by C2? That decides the condition to get a solution. In this case, A1 is 2 by 3, B1, B2 is 3 by 2. They are not equal. Similarly, 3 by 2 is not equal to minus 2 by 4. Again, it is not equal. So, such equations where you do not have the equal ratios, that would be called intersecting. The lines when you draw, we can draw a line for first equation, we can draw another line for the second equation. In a graph, when you draw, suppose this is the x and y axis. In a graph, it is x and y axis, and for the first equation, suppose you draw one line like this, and second line for the second equation, then that point of intersection will be the solution for us. That point will have two coordinates, x and y. We can then find out the value of x and y through this way, and this is called intersecting lines. In such cases where the lines intersect, you will have only one solution. Such conditions are called consistent. Now these are the 3 points you have to remember in each case. Suppose you call this as case number 1. In this case, you have two lines where the ratios of A1, A2 or B1, B2 and C1, C2 are compared, and if they are not equal, such cases or such lines will be intersecting when you draw on the graph, and there will be only one solution, and they are called consistent. Now we go for the second. Let me write down second condition. In this, we will give an example of 5x minus 3y minus 11 equals 0, and another example minus 10x plus 6y plus 22 equals 0. This is case 2. Now let me write down a1 a2 a1 by a2. This is nothing but 5 by minus 10. You can simplify this. 5 into 1, 5 into 2 with a minus sign. This also can be written minus of. Remember this, whenever minus sign is on the top or bottom, you can write down minus in the center for the easy calculation. Next is B1 and B2. B1 by B2. What is B1? It is minus 3 and B2 is 6. When you simplify, you get 3 into 1, 3 into 2, you get again minus 1 by 2. Thirdly, C1 by C2 is equal to minus 11 by 22. You can simplify this. 11 into 1, 11 into 2 is again minus 1 by 2. Here you can see A1 by A2 is equal to B1 by B2 and is equal to C1 by C2. They're all equal because in each case you got minus 1 by 2, minus 1 by 2, minus 1 by 2. In such cases, when they are all equal, then we can derive a solution, and they are called coincident lines. I explain you what it is. As I said, we are going to draw, we are doing graphically. Don't forget that. We are doing graphical method for getting the answers or values of x and y. For that, you require to draw lines. We draw one line for this equation, we draw another line for the second equation. Suppose this is a graph sheet, and this is x-axis, this is y-axis, and when you draw one line, suppose I draw one line like this for the first equation, and when you draw the second line for the second equation, you will find that it will coincide with that. It means second line will be overlapping. It's called coinciding with the first line. It happens only when A1, A2 is equal to B1, B2, when it is equal to C1 by C2. Now, in such cases, the solutions will be many. You will have many solutions. What is solution? Solution is nothing but values of x. Suppose you can find out many dots here because they will be coinciding. You can dot many points. Each point will represent one coordinate of x, another of y. So we'll have innumerable number of values for x as well as y. That's called many solutions. And thirdly, consistent. Whenever you have a solution, whether single solution or many, such cases would be consistent. The third case, we write down case number 3. Now let me write down some equations like 2x plus y minus 8 equals 0. Another is 4x plus 2y minus 15 equals 0. You find here also we have two equations. and x and y are variables. Let us compare A1 and A2 and B1, B2, C1, C2. A1 by A2 is equal to 2 by 4. A1 is 2 and A2 is 4. You can simplify this 2 into 1, 2 into 2, and that is equal to 1 by 2. Similarly, B1 by B2 is equal to 1 by 2. This is 1, B1 is 1, and this is 2. 1 by 2. C1, C2 is equal to minus 8 by minus 15. This also can be written as merely 8 by 15 because you can cancel the minus signs on both sides. 8 by 15 is C1, C2. You can find that A1 by A2 is equal to B1 by B2. That is 1 by 2 and 1 by 2. But that is not equal to C1 by C2 because this varies. C1, C2 is 8 by 15 is not equal to 1 by 2 at all. Now, this is case number 3. Now, what will be the pattern of lines when we have such case? That would be parallel. The lines will never meet. They will be parallel lines. I mean, suppose this is a graph, this is x-axis and this is y-axis. And when you draw a line for the first equation, suppose this is the first equation line, and when you draw another line for the second equation, that would be like this. That would be going parallel. As long as you move, the lines will never intersect. They will be parallel all along. That's why it's called parallel lines. When they are not meeting at all, there will be absolutely no solution. No solution. You can get a solution only when these two lines meet at least in one place. Now in this case, they are not at all meeting because they are parallel lines. When there is no solution, and that would be inconsistent. Now we have completed case 1, 2 and 3. Now we'll be shifting to the question place.